Good day and welcome to my next video on straight lines or y equals to mx plus c. Today we're going to be doing two more questions on straight lines and I hope to show you a few more new things regarding the y equals mx plus c. So let's go to our first question. Here we have a graph. We have a y-axis which is vertical and an x-axis which is horizontal. Now, I didn't write the question on the board, but we're going to do a few things with this graph. The first thing we're going to do, we're going to try to find the equation of this straight line. Now, in my previous video, if you're trying to find the equation of a straight line, usually you're given 2 points and you usually find m first, and after you find m, then you find c. Now, in this question, you'll notice something slightly different. I've only given you 1 point on the line. I did not give you 2 points on the line. And to find gradient, you usually need 2 points. However, believe it or not, this question is actually easier than the questions in the previous video. To find the equation of the straight line, we need to write down y is equal to mx plus c, and we need to find m first and c second. But you'll notice on the board, sometimes the examiner is nice to you, and if he gives you 1 point, he will usually give you the gradient. So, for example, when you read the question, the examiner might say, hey, the gradient of this line is 3. It's already given in the question, which means you do not have to do any work to find m. All you have to do is simply erase m and replace it with 3. So the gradient is given in this question, which means we do not have to use this formula to find m because we already have m. Our second piece of the puzzle to solve is we need c. Now to find c, we need 1 point on the line. Luckily, we have 1 point on the line, and that 1 point happens to be point A. So let's defer this here as x, and this is y. We don't have to call it x1 and y1 because there's no x2 and y2. Point A just simply means when x is 1 at the same point in time, y is 5. So to find c, we just have to go to the equation. Anywhere we see a y, replace it with 5. 3 was given to us by the examiner. The gradient was 3. X is 1. Make sure and replace the 1 in brackets. Plus c. All we have to do now is solve for c. 3 multiplied by 1 is 3. So to solve for c, we want c on that side and everyone else on the other side. Throw across positive 3, you will get minus 3, which means c is 2, or your y-intercept is 2. So remember I told you in your last video, you can't leave the answer for m upstairs and the answer for c downstairs. You have to write back the equation, the full answer in one straight line. So here we have m, we just have to erase c and put the value of 2 here. Now, in my last video, I really didn't explain what c represents in real life. Well, in a math question. I briefly explained what gradient meant. Gradient was just another word for steepness. So what about c? What does c mean? The y-intercept. Remember, y-intercept is the same thing as c. That just means if we were to draw this on graph paper, it would cut the y-axis exactly at, my mistake. The y-intercept is 2, so that means if we were to draw this on graph paper, it would cut the y-axis at exactly 2. So what would be the coordinates of this point? Well, anytime something slices the y-axis, your x value will always be 0. So what would be the coordinates of this point? The x coordinate would be 0 but the y coordinate would be 2. So just to summarize, gradient tells you how steep your line is. Y-intercept tells you, or the value of c tells you where it cuts the y-axis. And anytime something cuts the y-axis, x is always 0. And I can prove to you that whenever something cuts the y-axis, x is always 0. Let's go back to this equation here, right? Let's say you forgot that 2 was the y-intercept. Let's say for some reason you forgot what the y-intercept was. And somebody asks you, hey, this equation, where would it cut the y-axis? Another way of figuring out where it cuts the y-axis, if you already know the equation, is just to replace x with 0. Because anytime something cuts the y-axis, x will always be 0. And let's see what happens when we replace x with 0. Throw away the x and replace it with 0. Anything by 0 is 0. 0 plus 2 is 2. We got back the 2. So that's something worth noting. Anytime, any graph, whether it's a straight line or a curve, whenever it cuts the y-axis, x will always be 0. Now, in my last video, we spoke a lot about gradient and, well, we were calculating the y-intercept. But for some reason, we were not concentrating on where it cuts the x-axis. So let's say someone were to ask you, hey, if we were to extend this line and make it a little bit longer, and if we were to make this line longer, it would cut the x-axis somewhere. It must cut the x-axis somewhere. Here might be 2, 3, 4, 5, or 6. Sometimes in the exam, they love to ask you, what is the x-intercept? I'm going to show you how to find the x-intercept, or the value of where it cuts the x-axis. For this, we will need the equation of the straight line. We already found the equation of the straight line. This is m and this is c. Now, whenever something cuts the y-axis, x is 0. So whenever something cuts the x-axis, it will just be the opposite. Whenever something cuts the x-axis, you can assume that the y value is 0. Because when it cuts the x-axis, it has no height or no depth. The y value will be 0. So all we have to do now, instead of replacing x with 0, we replace y with 0. So let's replace y with 0 and let's see what happens. We have to solve for x because we're trying to figure out where it cuts the x-axis. So in between here and here, there's a secret multiply. So let's solve for x. We want x on one side, everyone else on the other side. We're going to throw across positive 2 to get negative 2. We don't have to write the 0, right? Because 0 minus 2 is still minus 2. Now we have to solve for x. Throw across the multiply, we're going to get a divide, but the sign does not change. So we will get minus 2/3. That means it will cut the x-axis at minus 2/3. And that's how you find the x-intercept. So just to summarize, once again, whenever something cuts the y-axis, you have to assume x is 0. If something cuts the x-axis, you have to assume the opposite, that y is 0. Alright, we're going to do a slightly harder question involving the x-intercept and the y-intercept again. So excuse me, let's continue with the second question. It's almost the same thing. I'm going to clear up this side so I don't have, actually I can leave it until I need more space. So, we're going to figure out two things. First of all, we're going to figure out the equation of this straight line. So we're going to find y equals mx plus c first. And then I'll add on some questions in. So let's find the equation of this straight line first. You have 2 points. Unlike this question, the examiner was nice enough to give you the gradient. In this one, he did not give you the gradient. So we're going to have to calculate the gradient. So, call the first point x1 and y1. The next point is x2 and y2. Let's calculate the gradient using that formula quickly. So to calculate gradient, it will be y2 minus y1. Remember, sometimes two negatives will touch you, give you a positive. So we have y2 minus y1 divided by x2 minus x1. Well, it seems that two negatives did not come together today. So, let me complete it here. 2 minus 20 is minus 18. Minus 4 minus 8 is minus 12. If we divide minus 18 by minus 12, we will get positive 1.5. So that means my gradient is 1.5. So, just like in my previous video, y is equal to mx plus c. We just figured out m is 1.5. We need to find c. C is your y-intercept. And to find your y-intercept, you choose any one of the points on the line. It doesn't matter if you choose B, it doesn't matter if you choose A. But I'm going to choose A because I always try to go in alphabetical order. So since A comes before B, I'll just choose A. Although it doesn't matter, we'll get the same answer either way. According to point A, y is 20, x is 8. Let's work this out. 1.5 multiplied by 8 is 12. We need to solve for c. Throw across the positive, we will get a negative. So c is 8. So let's write down the full equation of this one. Right? So I think I need space here now. But I want to leave. Nah, let's take everything off here. Right. So this is what we know so far. Y is equal to mx plus c. We know m is 1.5 and c is positive 8. So that's the equation of this line. Now, if someone were to ask you, hey, where does it cut what's the coordinates of where it cuts the y-axis? Remember in the previous question, anytime something cuts the y-axis, x is automatically 0. But we don't have to go and replace x with 0 because we know the y-intercept is 8. And anytime something cuts the y-axis, x is automatically 0, and we know the y value is automatically 8. That's the point of knowing the y-intercept. So we can actually visualize where it would cut the vertical or y-axis. But the x-coordinate is 0. Now, let's say someone asks you, where would this line cut the x-axis? If we were to extend this line, it would eventually cut the x-axis. Anytime something cuts the x-axis, you can be sure that the y value is 0. So let's calculate the x value. So we go to the equation of the line. We are going to replace y with 0, and we're going to solve for x. So to solve for x, we throw across positive 8, we're going to get minus 8. The 1.5 is a multiply, throw it across, we're going to get a divide. So x is minus 8 divided by 1.5, let's do that. And we're going to get minus 5.33. But it will go on and on and on. It's a recurring number you will get on your calculator. So that means the x value is minus 5.33. So that's how you find the coordinates of the y-intercept and the x-intercept, right? So I hope this video was helpful, and of course stay tuned to my next video. I'm going to do some more I'm going to move on to the midpoint of a line, length of a line, and afterwards we're going to do parallel and perpendicular lines. And then I'm going to show you how this topic, straight lines, is linked to that horrible, but that topic that is considered horrible, simultaneous equation. Yes, this topic and simultaneous equation are linked somehow. So, once again, if you need more information on these videos, or you're from Trinidad and Tobago and you need extra lessons in almost any subject, you can check the website for details. Alright, so have a good day and don't forget to subscribe and share the link.